Let's consider some more complex numbers. So first we're going to do an introduction right here. Say we have I times I. Well, I times I is the square root of -1 times the square root of -1, right? As defined previously. I is equal to the square root of -1. So then this is equal to the square root of -1 squared, right? So then if we write this in exponent form, we see that this is -1 to the 1/2, right? That's what square root of -1 is. And then all of that's squared. Well, whenever we raise an exponent to an exponent, we multiply these two guys together. So just 2 times 1/2 gives a 1. So this is -1 to the 1 power, which is just equal to -1, right? So we see that I times I, two complex numbers, I times I, yield a real number, right? -1. So let's consider some problems with this. So if we have I squared, so we have negative, this is going to be, as we showed previously, this will just be -1, right? But then this is equal to, we can write this down like this, I times I times I. And we see that this pair here will yield -1, but then this one will stay alone. So this will be -1, and then this yields a -1, so it's -1 times I, right? So this is -1 minus I, right? Okay, let's consider this guy. So we see that it goes 3, 5, 7, 9, so it's increasing in odd exponent numbers. So this, we can write this down as, this is I times I times I. This pair gives -1. So then this is going to be equal to -I, right? This guy can be written down as I to the 4th times I, right? But if you have I to the 4th is just, I times I times I times I. The pairs give -1, so they have -1 times a -1 gives a +1, right? So then we have plus I. This is +1 times I. Okay, and we could put the 1 here, for demonstration. And then for I to the 7th, I to the 7th is just equal to I to the 6th times I, right? But I to the 6th is I times I times I times I times I times I, like this. And you see you have 1, 2, 3 pairs. So this is -1 times -1 times -1. This pair, -1 times -1 gives a +1, then times the -1 again gives a -1. So this is, plus a -1 times I. And then we go to I to the 9th. I to the 9th is equal to I to the 8th times I, right? So then I to the 8th is just 8 I's. So that's 4 pairs of 2. So we have 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. So we see have this pair, this pair, this pair, and this pair. So that's -1 times -1 times -1 times -1, like that. So these two yield a +1, and these two yield +1. So then this will be plus +1 times I. And I'll tell you what I'm going to do. For right here, I'm going to put, because this is a good way to demonstrate it. This is I squared times I, right? This yields -1 in front times I, and then this yields a +1, right? I to the 4th is +1 times I, and then I to the 6th yields a -1. And the I to the 8th yields a +1. And my eyes are not looking so great. Okay. Looking like J's. Actually, well, backwards J's. In electrical engineering, they use J instead of I. I don't know why. Some historical reason, I'm sure. Okay, so then look, we have negative I, plus I, minus I, plus I. So look, they all just cancel. We have negative I, plus I, minus I, plus I, and, you know, bang, 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 0. Okay? So this one here, I squared is negative 1, so we have negative 1. This is equal to I squared times I squared, isn't it? So then I squared times I squared, negative 1 times negative 1. Negative 1 times negative 1. And then this thing is equal to I squared times I squared times I squared, right? There's 3 pairs. You can say I squared times I squared times I squared. And so you have negative 1 times negative 1 times negative 1, like that, right? And let's see here. I'm going to end up running out of space. I can see it. So this is just negative 1. I'm write it like that, negative 1 cubed. And then this will be equal to I squared times I squared times I squared times I squared. Each one of these is negative 1. So this is plus negative 1 raised to the 4th power, right? So we have negative 1 and then positive 1. And then negative 1 cubed gives a negative 1 again, because negative 1 times negative 1 gives a positive 1, and then times another negative 1 gives the negative 1, right? And then this will yield a positive 1. Because we have negative 1 times negative 1 gives a positive 1, and then negative 1 times negative 1 is positive 1 again. So, okay, so then we see that these cancel, right? This cancels, 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 cancels. There's, you know, minus 1 plus 1, minus 1 plus 1, so the answer for this one is 0 as well. Okay, so this is just some more situations that can show up with the complex number that you might be tested on. I'm going to step aside, give you a clear screenshot, try for yourself.